A particle starts from rest and accelerates uniformly to a velocity of 6 meters per second in 9 seconds. It then undergoes a constant negative acceleration, so after a further 6 seconds, its velocity is minus 3 meters per second. Draw a velocity time graph, find the total displacement and the total distance. So as the acceleration is uniform during each stage, the graph will consist of two straight lines. So if we draw a set of axes, okay, when at 0, the meters per second will be 0 when time 0, but when we get to 9 seconds, the velocity will reach 6, and then after a further 6 seconds, so 9 plus 6 is 15, it will become minus 3. So therefore we need to draw lines like that, and that is my velocity time graph. The gradient of the graph represents the rate of change of velocity, i.e. acceleration. So the acceleration here will be 6 divided by 9, the gradient of the graph, which is 2 over 3, and the gradient here will be minus 3 over 2. So for every 2 along we will go 3 down. We can see that very clearly from our graph. In calculus, this relates to A being equal to dv by dt. Just drawing the graph again. The area under the graph and the horizontal axis gives displacement. So the area here will be a half of 13 times 6 over 30, which is 39, and the area here would be a half times 2 times minus 3, which gives me minus 3. So the total displacement will be 39 plus minus 3, which is equal to 36, and the total distance will be 39 plus 3. You ignore the fact that it's minus, so the total distance travelled would be 42 meters. Okay, so slightly different thing here. If you were using calculus and you wanted to find the displacement, then you just have to integrate the function from between 0 and 15. And don't take into account whether it is above or below the axis. It will give you the correct answer. If you were talking about a distance, then you'd have to integrate the absolute value of the function. So you have to make this bit positive. So in calculus, this relates to the displacement being the integral between a and b of vt dt, and the distance will be the integral between a and b of the absolute value of vt dt. Now we can see this quite clearly in this applet here, which is underneath this video. If I move t, you can see here the distance and the displacement are exactly the same. Let's see if we get to 13 right. And we get to 13, they are the same, i.e. 39. However, if we go past that where the graph goes below the axis, the displacement becomes 36. When we get past this particular value, you can see here the displacement is 36 and the distance is 42. So to get distance, you'd have to integrate the absolute value of the function, which is that. Okay, but to get displacement, you just would have to integrate the function from here to here, and you wouldn't have to take into account of it being below or above the axis.